previous lesson, we were able to prove the cosine rule. So today, we are going to prove that sine A all over A equals to sine B over B, or sine B all over B equals to sine C all over C. And remember, you can combine any of them because a triangle has 3 sides, so we are including all the sides. So it depends on the triangle that is given, and so if you are given a triangle that is not a right angle triangle, that is when you apply the sine rule or the cosine rule. So now, how do we prove this? Consider this triangle. If you want to find the height of this triangle, we need to divide this triangle into 2 parts. This other triangle is bigger than this, so we can say that this is the height of the triangle H. The height of this triangle is H. And now, if you look at this, since we have divided this triangle into 2 parts, we can label this as D. We can label this other side as D. So now, from this point to this point is the side. The side here is opposite to this angle here. This angle is opposite to this side, and this angle is opposite to this side. So we use small letters to denote it. This is how we label a triangle. So now, since we now know that this angle is opposite to this side, we are going to consider, we are looking at this, how to get something similar to this. So we are going to find sine A from triangle ABD. From triangle ABD, we can see that sine A equals to what? Remember, sine is what? Opposite over hypotenuse. So this is the opposite and this is the hypotenuse. Hypotenuse is the longest side of the triangle, and the opposite is the side that is opposite to the angle. So if you are considering this right angle triangle, this will now be the opposite and this will be your adjacent. So in sine, we make use of what? Opposite over what? Hypotenuse. So opposite is what? The height all over what? The hypotenuse, which is what? C. So you can see that sine A equals to H over C. So to find the height of this triangle, that will be H equals to what? C sine A. So you can take this as your number 1 equation. Now we can also consider triangle BDC. So we consider this triangle. If we look at this, we also find the height by saying sine C equals to what? Opposite over what? Hypotenuse. So this will now be the opposite and this will be the what? The hypotenuse. So you can see that the height can also be calculated by saying A sine C. So since the height is equal to A sine C, which is equation 2, we can say equating both equations, equating both 1 and 2. So if we equate equation 1 and 2, you are going to have that A sine C equals to C sine A. So the height can be calculated. The height of this triangle can be derived by using this formula, and the height can also be derived by using this other formula. So this is the same thing. So that's why we're equating it. So if you say divide through by sine C, you are dividing through by A. You have that this all over this and this all over this. So this will cancel this, and you have sine C equals to C sine A over A. So you can also say equally say divide by C, dividing through by C, dividing through by C. So you have sine C over C equals to sine equals to, so C sine A all over A. Then you divide by C, meaning that you're going to multiply by 1 over C. So this will cancel this. And we're now having that sine C over C equals to sine A all over A. So I told you that you can combine any of them. You can combine this and this, this and this, or this and this. So this is sine C over C equals to sine A over A, or you can write it sine A over A equals to sine C over C. So this is the proof of the sine rule. Thank you.